Hi, in this video I am talking about the edema and its mechanism.
In this slide, you can see some images of edema. So we'll see the definition. So edema means the buildup of fluid in the body tissue. So we'll see how the fluid is building up in the body tissues. So for that, we'll see the mechanism of edema. I said earlier, edema means fluid buildup in the body. So building up of fluid inside the body tissue. So we must know what are the fluids present in our body. Our body fluid compartments is divided into two, mainly two, that is one is extracellular fluid volume and also the intracellular fluid volume. That is around 20 percentage, and the intracellular fluid volume, that is around 40 percentage. Total there is 60 percentage of body fluid compartment is there. Okay, so 60 percentage of our body is built up of water. So now we can say like the extracellular is further divided into plasma and the interstitial fluid. The interstitial fluid means the fluid which can see around the cells, okay, or between the cells. And the other third compartment, that is called transcellular fluid, that is a distant collection of fluid which is a small volume, so we'll calculate it as the interstitial fluid. So the main thing we need to understand that our body is made up of fluid which is 60 percentage, and that is divided into main two things, that is extracellular and intracellular. So the intracellular is a 40 percentage and the extracellular is a 20 percentage. So before explaining the mechanism of edema, I would like to explain the systemic circulation. Everybody knows regarding this and it's a quick review. So the blood from all of the body which is carried by this superior vena cava and the inferior vena cava to the right atrium. From the right atrium it's go down to the right ventricle through the tricuspid valve. From there the pulmonary artery which carries the blood to the lungs for the gaseous exchange or for the oxygenation of the blood, and from there the oxygenated blood which is comes to the left atrium through the pulmonary vein, then to the left ventricle through the bicuspid valve. From there the aorta, which is the largest blood vessel in our body, which carries the oxygenated blood into our body tissues. Okay, then you can just see that this aorta, that which turns branches into arteries and then arterioles, then to blood capillaries. Okay, then it reaches into the cells and the tissue cells, so it's got perfused. Then what happened is then it enters into the venous network again. Then from there this inferior vena cava, through the venous network it enters into the inferior vena cava and the superior vena cava, and it reaches into the right atrium. The whole process, it's a continuous process. So that is the systemic circulation.
So here in this slide you can see the capillaries, you can see the pores. See, this is the microscopic examination of a capillary. So I want to say that the arteries and veins are like pipes and it is a closed circuit, but the capillaries are different, which has pores. Okay, see, you can see here which has pores and it's known as fenestrations. These fenestrations allow the substance to enter and exit the bloodstream at the cellular level. We are talking about the capillaries which is only a single cell thickness. Okay, this capillaries has only the single cell thickness and it has fenestration, and it allows to enter and exit the nutrients and fluids. You can see a blood vessel, that is a blood capillary. Then you can see the pores, that is called fenestrations. And as the blood flows into the blood capillaries, there is a pressure, that's BP, that is about 120 mm of Hg, with the fluids to move. Fluids, I am talking the blood. Okay, we already know normally when the blood flows into the blood capillaries, it pushes the fluid and nutrients down, and there will be a downward force, and which is called hydrostatic pressure. Okay, the normal, I am talking about the normal cases when the blood flowing into the blood capillary, the fluid and nutrients is that there will be a downward push and pushing down, and it reaches into the cells, and the force is called the downward pull. The pushing force is called the hydrostatic pressure. Okay, this is up to the arterial end. Okay, this is the arterial end. Okay, what do you mean by arterial end? As I told you before, in the circulation there will be artery, first aorta, then it branches into arteries, then arterioles, then arterial capillaries. Okay, this happen at the arterial end. Okay, what happens after the it reaches into the cells? When it reaches into the cells, the uh, to the cells, this is the blood is enter into the venous system again. Okay, venous system, and then going back to the venous capillaries, then veins, then major veins, superior and inferior vena cava, then to the right atrium. That's how the circulation occurs. Okay, so this hydrostatic pressure at the pushing down of the nutrients and fluid, which is happening at the arterial end. Okay, then we will see what happens at the venous end. So we will see what happened at the venous end. Okay, I told in the arterial end there will be downward forces. So here we will draw, there is a pushing down forces. So here they're pushing down. So the fluids and the nutrients will be reaching in between the cells, interstitial space. Okay. Then at the venous end, what happened? There will be opposite force, that is called oncotic pressure. Okay, there will be opposite force that is exerted by the protein molecules. Mainly the protein molecule is albumin, which binds with the water. Okay, which allows the, which hold the water in the albumin, so which is exerting a upward forces. So whatever the fluid and nutrients is pushed back, that will be pushed in. So that is counteracting forces. Okay, one force, that is hydrostatic pressure, that is pushing down the fluid and nutrients, that is at the arterial end, and the venous end, what happened? There will be the counteracting force which is pushing back again into the bloodstream. So there will not be any fluid will be accumulated in the interstitial space. Whatever pushing down in the arterial end, in the venous end, it is pushing back. So that's how the plasma volume get maintained in the bloodstream. Okay. So if the pushing force there, so the I'm talking about the oncotic pressure, that is pushing up, still there will be some amount of fluid will remain in the interstitial space. What happened about that fluid? Okay, the amount of the fluid that is remain after this oncotic pressure, after the pushing back into the bloodstream, it will enter or drain into the lymphatic system, and this will again join to the circulation. So there will be no fluid will be accumulated in between the cell, that is interstitial space. So you cannot see any fluid, that is in the normal cases. So what happened if there is lymphatic system failure? Okay, if a person who has the lymphatic system failure, the extra fluid which is present in the interstitial space cannot drain into the lymphatic system and cannot reaches into the circulation. That time the interstitial fluid, it will be remaining in the in between the cells, and there will be fluid accumulation, that is building up of the fluid, and edema can happen. That is the first thing, that is a lymphatic system failure. And the second will be, as I told, when the blood flows into the blood vessel or the blood capillary, there is blood pressure. Um, that is, that the pressure allows the fluid to push down. Okay, that is called the hydrostatic pressure. Okay, what happen if any increase in the blood pressure, that is hypertension, the hydrostatic pressure also increases and the more and more fluid and nutrients will be pushed down in between the cells. So there will be more fluids in between the cells. So that is also one reason. So more and more fluid will be in the cells than the normal level. So there will be accumulation of fluid in between the cells. So that is also one reason, hypertension. So the next reason of edema is, everybody know there will be albumin in the blood and this albumin is holding the water in. Okay, so the albumin is a large molecule, so it binds with the water, because if the water can stand alone, with this albumin the water is binding, okay, with the albumin. Okay, when in case of cirrhosis of liver, the albumin production is less. Okay, so there will be insufficient albumin. So what happening in the bloodstream, there will be albumin is less. So the water that will be, cannot bind with the enough albumin. So the water molecules are small. So this water can easily it can be pushed down. Okay, pushed down. The more and more water can be pushed down in the interstitial space. Okay, that is the another reason for the edema. Okay, that is another reason for the ascites in the case of cirrhosis of liver, because of the insufficient albumin production. The third reason for edema is in case of burn and also like crush injury, there will be endothelial cells of the capillaries got damaged. The damage mean the space. Okay, I told there is a pores or fenestration. The size of this fenestration, okay, the size of this fenestration is increases. So like this it increases. So if it increases, what happens? The size of the fenestration, the pores are like it become big. So you can see the pores are big here. So there will be damage in the endothelial cells of the blood capillary. So these large molecules, that is protein, can be easily escape into the interstitial space. So these are the causes of edema. These are the basic mechanism in the edema. So I think this will be sufficient for the edema mechanism, and we'll be back with another video. So stay tuned. Thanks for watching.